Today, I want to talk about this problem unique path because I was having trouble with the optimal approach using dynamic programming and memoization. Before I start, I want to briefly review dynamic programming, memoization, and auxiliary space. Dynamic programming is mainly an optimization over recursion. The idea is to store the results of subproblems so we don't have to recompute them later when needed. It improves performance by reducing time complexity from exponential to linear. And memoization is one of such techniques. As answers to the problems are found, they're stored in an object or array, so these results are never calculated twice. Another thing I learned is that there's actually a difference between auxiliary space and space complexity. Auxiliary space is extra temporary space used by an algorithm to reach its solution, while space complexity is total space taken by the algorithm with respect to the input size. For example, insertion sort uses O of 1 auxiliary space, but its space complexity is actually O of n. Let's now dive into the problem. A robot is located at the top left corner of an M by N matrix. The robot can only move either down or right at any point of time. The robot is trying to reach the bottom right corner of the matrix. So the robot starts here and wants to end up here. How many possible unique paths are there? Here's a diagram for easier understanding. So this is a matrix with a column with 3 columns and 2 rows. We can break it down into subproblems. Each cell actually has its own unique path, and because the robot can only move down or right, so we know that if there's only one row or one column, then there's only one path to the endpoint. So for example, if we want to get to this cell, there's only one way, right, from the start. But if we want to get to this cell, there's 2 ways. The robot can move to the right, down, or the robot can move down, then right. Notice the relationship between these numbers. 2 is the sum of 1 and 1, and 3 is the sum of 1 and 2. So every time we calculate the number of unique paths to each cell, we can store them in a matrix, and we can use the stored values, then calculate the rest of the path. And this is where memoization comes in. So let's see what it looks like in a function. In the optimal solution, we are using recursion. So the function takes in 3 arguments. M represents column, N represents row. Then we have a memo matrix we create ourselves to store the number of unique paths to each cell in its respective position. So the matrix looks very much like the matrix here. We're just using JavaScript functions and arrays to create a matrix. The reason we need to add 1 to M and add 1 to N is because we will be using the number of column and row to index the matrix later. So for example, if we need to index this matrix, we need to add 1 to the column and add 1 to the row. So the index starts at 0. So we already know that if there's only 1 row or column, there's only 1 path to the endpoint. So we just return 1, and this will be our base case. In order to understand the recursive case, let's go back to the diagram again. We want to calculate the number here, and the position of the cell is at column 3 and row 2. But we can't calculate the path until we know the path to the cell above it and the cell to the right, to the left. Same thing applies to these cells. Therefore, we recursively call the function until we reach the base case where we either have 1 row or 1 column. Then we return 1. We add the 1s and store the sum in the matrix. We then use these store values to calculate the rest of the path. And that's what's happening here. We then return the final value of the path. So if we console log the matrix, this is what it looks like. We have 2 stored in the matrix and 3 stored in the matrix. This approach has a time complexity of O of m times n, since we're going through each cell of the matrix, and the auxiliary space of O of m plus n, since we have up to m plus n calls on the stack at any given time. I hope this video helps us understand dynamic programming and memoization more, and thank you for watching.